name is Jim White, folks. What is our agenda here for the next hour and 40-some minutes? Is that we're going to talk obviously about what Android is and get a look at the general architecture of Android. We'll take a look at the development environment. What do I need to start to develop an Android application? We'll also look at what an Android project includes. In particular, as most of you who would be doing Android development is probably going to be through some sort of IDE. We'll take a look at what a project in Eclipse looks like. For those of you who come from a .NET background or from another programming environment background, I know that'll be a little bit foreign, so we'll try and walk you through that. And of course, as we look at just what a normal Android project would look like, everybody wants to do Hello World. It seems like if you're not doing Hello World, it's just not a valid computing platform. So yes, we'll take a look at Hello World. In fact, interestingly, in Android, every project you create by default is Hello World. So most of the Android people agree with us there. We'll also take a look, though, at building more complex applications. We'll be taking a look at what are the building blocks, what are the major components that Android provides for making an application. Yep, we'll actually see some sample code there. Some of that, obviously, given the time frame that we have, will go by a little bit quickly, maybe more quickly than you would like. The idea is to give you a general understanding of what the pieces and parts are about there. Obviously, you're going to need to do some more work to go out and research that. Of course, we would encourage you to come to our class. And lastly, we'll talk about some development considerations. What are the cool things that supposedly Android has to offer that, yep, some platforms may also offer, but that are considered kind of the reason why people are looking at the Android platform. And then also, what are some of the things that people really like about Android that others claim really are Android exclusive? And we'll also give you kind of the negative. I also believe in any time you talk about software engineering, there is no free lunch. It's always about yin and yang, understanding what are the positives, but also understanding what are some of the issues and concerns that are out there. So we'll take a look at some of those from an Android perspective as well. And we'll wrap up with what your questions might be. Given that, what is Android? Many people probably heard that Android is a Linux kernel, or at least if you haven't, here's your introduction to that. So unlike some of the other platforms out there that you might find, we're dealing with a platform that probably you've seen even in your server environments to some extent. It is modified Linux. Obviously, the devices are beefier than what they used to be many years ago, but certainly not that beefy to run everything that you might think of in terms of Linux. It was originally built for mobile devices specifically, but that's being expanded quite a bit, and I'll speak more to that in just a second. Built originally by the Android company, purchased by Google in 2005. So everybody associates Android with Google for right reasons, since they're now the owners of Android, or at least the main initiators and drivers of Android. But it really was a separate company, separate project out there. Google's now, if you will, under something called the Open Handheld Alliance, at least to some extent. The Android open source project, which really drives and keeps the maintenance and further development of Android going, is led by Google. So anybody who thinks that while this is an open source project and is something that people can participate, anybody who thinks that Google doesn't have a heavy hand on Android, well, you need to go read some blog sites and some documentation. Google has a pretty heavy hand on this platform to date. I'm not saying they're doing anything necessarily wrong with that. It's just it is still heavily Google favored.
Conference center.
As I mentioned, this is a platform.
Thank you. The host has not yet arrived. If you are the host, please press the star key. Please enter your moderator code.
Netbooks, there are Android tablets.
For operator assistance at any time during your call, press *0.
Android media
The conference is now in silent mode.
And now even Android TVs are soon to hit the market if they're not already out there. So this is a platform that is gaining legs in lots of areas, but in what I would call the resource-constrained, limited device kinds of capability. Not that some of your TVs couldn't be extremely powerful and extremely capable, but most of these electronic consumer devices aren't built to run your VB2 database. They're built for home use, that kind of thing. So it's a platform that's being very well supported in those environments. What does the architecture of Android look like? Again, at the foundation is Linux, specifically version 2.6 for those keeping score at home. As part of that kernel, lots of drivers to run the screens and all the other pieces and parts of our environment. C and C++ libraries make up a large component of that kernel. Most of that's exposed through the application framework. We'll talk about that in a second. On top of that, you have the Dalvik virtual machine as part of the Android runtime environment. You know, I'm, as you could probably tell in some of the earlier discussions, I am a Java developer by trade. Yep, getting into some of the .NET stuff. And so this is a Java platform, at least by and large a Java platform, but it ain't the Oracle/Sun Java platform. In fact, there's a point I want to make about that here in just a second that could be a bit of an issue, and we'll bring that up here in just a second. So it is a virtual machine. It is a Java virtual machine, but it's not Java SE. It is not Java ME, not Java Enterprise. It is the Dalvik virtual machine. To that point, too, yes, you do have a lot of the standard Java libraries, which you've probably become accustomed to, but you don't have some things that you've become accustomed to in the Java world. For example, there is a Java Swing out there. There is a Java RMI. There's not a lot of the enterprise APIs. And there are a lot of Android-specific Java APIs, which we'll talk about here in a second as well. And, oh, by the way, each application that you would build runs on its own process, on its own instance of that DVM. So essentially the DVM is meant to spin up lots and lots of applications out there, each one kind of being its own little tunnel. On top of that, we have the application framework. Again, minus some of the Java SE library classes, but in addition, we add a lot of the Android libraries specific to doing things like, well, stuff that you wouldn't ordinarily find on your desktop, your laptop, things to drive the phone, things to drive a camera from the Java code perspective, things of that nature. And on top of that, you build your applications. Now, your applications do get written in Java, or at least probably written in Java. We will speak about some of the other languages that might be an option to you here in just a second. So you're probably running in Java. They're compiled down to class files, but then beyond that, they're then compiled or built into, or however you want to view it, into what are called DEX files, or Dalvik executable files. These are what actually run on the DVM, on the Dalvik virtual machine. By the way, if you're wondering where that name came from, the inventor or creator of the Dalvik virtual machine, Dan Bornstein, I think if I've got that name correct, his ancestral home is in Iceland. I guess that's a small fishing village in Iceland, so that's where the name comes from. Now, it's that virtual machine that's at the heart of the Google/Oracle/Sun lawsuit. You may have read about that. The reason why Google pulled out of things like Java 1 recently, and you usually see it in a lot of the business papers and things of that nature. It hasn't been worked out yet. I'm not sure what the results of this are going to be. But the idea is that the Dalvik virtual machine, according to the Android/Google camp, was a clean root implementation of Java in the Java virtual machine. Oracle/Sun claim that's not the case, that they have stolen a lot of intellectual property. So obviously that is a point of contention to which we'll have to wait and see how that works itself out. A lot of investment, obviously, from the part of Google on this technology, and it's not going away. But obviously that lawsuit leads to some questions in all of our minds about, well, what does that mean going forward? Not quite sure yet. Interestingly, I'm not sure if any of you follow the technical papers. Just, was it yesterday or the day before, James Gosling joined Google. So that will be an interesting step forward for that organization, and seeing how they obviously put a lot of emphasis in the Java environment, not just in Android, but lots of things. That will be an interesting development, and seeing how that manifests itself out and how that goes forward with regard to this particular platform. Okay, a little bit more of a detailed picture of those same layers. Again, the kernel at the bottom, your Wi-Fi drivers, your memory drivers, things of that nature at the bottom. On top of that, the libraries. And oh, by the way, you might notice there's a SQLite there. You'll notice that above that, we've got our application framework to drive our applications, and then our applications go on top of that. And yep, Android comes with a number of applications already pre-built and typically installed on the device. The device manufacturers get to dictate that a little bit, but there's also a lot of common applications you'll find on all the applications. And indeed, one of the nice things about Android is the sharing of information and sharing of services and things of that nature is actually part of the Android platform. It's built in. It's intended to be that way. They want people to offer applications that share data and services. and be able to kind of announce that to the rest of the things on the platform. So we'll talk about that. So even when we talk about applications up there that may not be yours, you may leverage those, and often cases will. Okay, so what do I need to develop an Android application? You need a JDK. Even if you're going to be developing in other environments, which I'll mention here briefly in just a second, you're still going to need a JDK, which today means you need either Java 5 or Java 6 environment. You need what's called the Android SDK starter package. The SDK will be important to your development, but you don't go out and you don't download, I should say, the entire SDK right away. You download the starter package, which really isn't all that much. We'll talk about that in just a second. The SDK, including the starter package, comes on platforms for Windows, Mac, and of course, since it's Linux-based, those guys said, hey, how about the Linux guys? When you get the starter package, what you're really getting is a kind of a small little, I'll use the term kernel loosely, don't think about the Linux kernel, but a small little couple of files, one of them being the Android bat file, which is, at least for the Windows platform, is really your starter package. That's nothing more than a little UI that drives your ability now to go out and get the rest of the SDK. Now you might think that's a little bit unusual. Why don't they just give me the freaking SDK? Why do I have to go through this extra step, get this little piece started up, and now use the web to go out and get the other pieces? Well, the thinking goes along this line that when you're building for Android, remember all those devices that they potentially support? Yep, mobile devices being one, but all the way now up to Android TV. All the different types of devices, all the various versions that might run on all those devices, all the capabilities you might want, well, maybe you don't need all that. And to go and get all that, they say, well, that's probably extra stuff that you don't, want to download, have to set up, get configured, all that kind of thing. So the idea behind it is the starter package allows you, through this little window, to go out and say, okay, now that I've got my starter, here's the the Android environment that I want to develop to. Maybe I'm only going to develop applications that are going to run on Android 2.2. We'll talk about what the different versions are here in a bit. Fine. You click the button and say, just give me now the SDK for 2.2. So this allows us essentially to kind of hone in on what particular parts of the development environment we really want. Now, having said all that, Jim just goes out and says, click all, give me all, which a lot of developers do. All right. So that's usually if you're looking at developing for these kinds of devices, these types of applications, you want to support as many as you can. So you usually grab them a big swath of them anyways. Interestingly, too, Google always wants to give you their Google APIs a lot. And so what we find, too, is some of the options up there is, do you want, say, for example, Android 2.2? And then the next option below that is Android option 2.2 with Google toolkits and things of that nature. So there's all sorts of stuff out there, that some of which cases you may want to eliminate some of that stuff. Right? Okay, so you get your starter package. You use the starter package to get the rest of your SDK. What else do you need? You don't need anything else. Don't need anything else, but highly, one more time, highly recommend we go and we get also an IDE to help build applications on top of that. Now, today, that means Eclipse, really. Yeah, there are a couple of options that I'll talk about that aren't really great options yet. So Eclipse is really the environment that you're going to be finding you're going to probably be building applications for if you want the least amount of pain, you want to get up the quickest. There is a built-in plugin for Eclipse already out there. Engine, and for those who use Eclipse, you're probably very familiar with the install new software option to get a plugin. That's how you get the Android plugin for Eclipse. Again, you don't have to have that, but it does make life a lot easier. In particular, if you're developing and you have a real device and you want to get your code on that actual device through your USB cable, well, they have a nice capability there, but it's literally a export file type of operation, and it's pretty much done. Otherwise, you're dealing with lots of batch files and trying to create the right, what amounts to a jar file, not called that, but amounts to a jar file to get shipped out to the device, and it's a little bit more herky and jerky to try and get things accomplished. If you're looking outside of Eclipse, the SDK is a collection of tools to help compile, build, generate your application. And those raw tools can be used with any IDE. Even the Android developers can plug into any IDE out there. In fact, a lot of people do for things like NetBeans and for things like IntelliJ. They'll even find blog sites that tell you exactly how to do that. But you've got to essentially roll your own there or bake it into your IDE today. Now, some people with some initiative out there have gone up and set up either some help with that or some toolkits to help with some of that, but these are not officially supported under the Google environment. In fact, if you go out and you read the Android developer site, they pretty much tell you you're a bit on your own. So just know that this is something that, hey, if you're going to do this, it's not really within the realm that is in, if you want to call it support for open source project support of the Google community yet. But a lot of people are doing it. Oh, by the way, there are also Apache Ant tasks out there. So if you're the type that likes to use a raw editing tool, a JEdit, or the Apache Ant commands, that's well established out there as well. If you want to use other JDKs to build your application instead of building it on top of or I should say running on top of your development environment Sun JDK, the developer side also says, well, we believe it will work, or they use the term may work. In fact, they've tested it to some degree, but they'll tell you quite up front that it may work, but we're not going to guarantee it. But in particular, they mentioned OpenJDK as well. No guarantee. So if you're a believer in using one of the other JDKs out there, you're pretty much on your own at this point. And if you don't like Java, what do? Well, there's also something relatively recent in the Android community, something called the Native Developer Kit, allowing for the development of C and C++ applications out there. You still have to use that in conjunction, though, with the SDK. And so that means you still have to have Java out there to run a lot of the tools and get things working out there. So even though you might be writing applications in C or C++, you still have to have your Java environment available to you. I don't know a tremendous amount about the Native Developer Kit. Haven't had a chance to use that yet, so I can't speak too much more than that. But there is how about other languages, Jim? Well, not really for you. None for you. All right. Yeah. If you're running on Java, again, in theory, and particularly those applications, or say those languages that run on Java, your Scalas, your JRubies, your Groovies, are supported as well. In fact, there are some blog sites and websites that even have people touting about how they've written this wonderful Android app in Scala or other programming languages that you're running on top of Java that then gets compiled down to the GDK and things of that nature. So this is, again, something that if you look and read a lot of the Android information, something they want to start to support eventually, but they're not there yet. Right? So a lot of this you're going to be doing on your own. If you're going to step VM realm, then you're really on your own at this point because you're essentially going back to the native development environment, C and C++, and trying to build on top of that, and that gets pretty ugly right now. You do not have to have a device to write an Android app. Good. In fact, the emulator comes with a lot of capability to help you simulate things like phone calls coming in, things of that nature. So the emulator is pretty good. Nothing beats the real device. That goes for just about any mobile development. Everybody who does mobile development will tell you, before you obviously ship, which goes without saying, you want to try things out on the real device. But in particular, you're going to find you want to, if you've got a particular user interface feature, you want to test on several devices. Android wonderfully has built the idea into the application project and the application. Actually, give you the project environment to do that in. In other words, we'll support the application being sent out to multiple UIs, but nothing really beats putting it on the actual device. Now, here's where building to Android, at least from everything I'm hearing, reading, and working with, here's where Android has a little bit of plus up on some of the other environments. To get that application that you're writing right now in Eclipse on your device is pretty much, especially if you're using Eclipse, it's pretty much drag up a menu, export, boom, connect with USB device. You got to do a couple things on your device to make that work. In other words, you have to configure your device to say, give this guy permission to put an app on it. As you would probably presume, you don't just want that thing opened up wide to the world. So you have to actually tell the Android device, allow me to be kind of in developer mode, allow applications to come directly onto me. Some of that earlier in the panel discussion about, you can make an application available through your website and let people use it and download it. Some of that stuff with regard to making your device aware that other applications are coming in from something other than like the Android market. That could be some interesting, install instructions you have to put on your website to help make some of that happen. But it is certainly possible and really a great benefit when you look at it compared to some of the other device platforms out there. The emulator, as I mentioned, really it comes again with the Android SDK. And notice that's the SDK. That's not, you don't have to have Eclipse to get the emulator up and running. Although again, Eclipse has built-in capability to launch it as you might see fit. The neat thing about the emulator too is it's a mechanism that retains all the information, unless you so choose to read it all. It retains all the information, the interaction you have with the emulator. So if you put an application on there, even when you go and shut the emulator down, you bring it back up, it still remembers your app just like your device does. It remembers if you put like contact information in it, it remembers those contacts. It retains, has the persistence to keep all that information on there. In fact, it's kind of funny because I've run into a couple of cases where I renamed an application or something, and now it has the two versions of the application. I'm pushing the same icon, thinking, why isn't this thing changing? It's because I forgot I had to actually go back and uninstall it from the emulator. So you have to remember to uninstall your applications from the emulator. That's kind of fine point that you start to think, oh yeah, this thing really isn't the real device. Okay, to set up the emulator, you'll again go through something called the SDK manager. That's the same tool that comes with the SDK that helps you, download the rest of the pieces for your SDK environment. The AVD manager, Android Virtual Device Manager, allows you to create your emulators. The idea is when you went to your SDK, remember I said that's when you choose version, the kinds of devices you're planning to build for. Well, the AVD manager then says, okay, now let me build an emulator for my device. It allows you to establish versions that emulator is going to emulate. That makes sense. It's going to allow you to establish the amount of memory that's going to be simulated for your SD card. If you're familiar with the Android device, see your flash drive on that device, how much memory it's going to have, other capabilities that you want on that particular emulation. Allows you to set it up. You can have all sorts of these emulators. So you can say, well, let me build one for a particular platform now or a tablet, whatever it might be, and test out your application across many of the environments. So it really is a manufacturing mechanism to your emulation environment out there. The AVD manager is something too that Eclipse has built in with Eclipse plugin, is built right into Eclipse. There's a launch to essentially bring this up and kick off any of the AVDs that you create. When we talk about there are many versions of Android, even though it's a fairly new platform, many versions of Android, and by default, Android and the devices and what have you expect you to support all devices, and by all devices I mean all versions and all types of devices. It doesn't care. It assumes you are building an application that is just as good for that tablet as that TV, as that old version 1 point whatever. And you have to specify what you really want. And how you do that here in just a bit. So a fairly simple process is setting it up with something called test file, which determine what versions, levels, what size and shape devices you actually want to support out there. Now, there's a little bit of goofiness. I find this goofy. I don't know if you do or not. Android, there are Android versions, but then you also see that every Android version something called an API level. Depending on which UI you're looking at, which tools you're looking at, these two are used interchangeably. They're linked. But they're interchangeably, and that's a little bit tough to get used to, because in some cases you'll picture saying, hey, what version do you want to use? Let's say it's what API level you want. It's all the same. It's just the way they kind of enumerate things. So there are different versions you see out there, and then different API levels. They mean thing. API level is just equal version number, if you will think about it that way, whereas the version number kind of goes like you see with software. The latest and greatest says 2.3. Actually, that is a misnomer in that version 3 just came out here relatively recently. So there's now a version 3. In particular, that version is targeted at tablets, given all the tablets that are coming out this year. no wonder as to why it's being rushed out there right now. There's also, by the way, a version 2.2 now, which is called API 10, and 3 is actually API 11. So gives you some idea about how some of that goofiness works. And if you're wondering, okay, so if I build an application to Android, which version should I choose? There's the distribution up there as of February 2011. Nice thing about the Android developer site, this is a statistic, this is a graph, this is information. It's right out there on the Android developer site. So they give you the latest and greatest information about who's using what based on all the devices and things that are out there. As you can see, even though the API levels keep going, and we'll talk more about versions here in just a bit, even though the version numbers keep on rolling, you're still limited by what the manufacturers are pushing out. So Android's updating about every 6 months. The devices are updating maybe once a year, and not everybody, I don't know about you, but I'm not buying a phone every year. At least I haven't been able to talk my boss into that yet. So have to keep in mind that even though the greatest Android API may be out there, what the devices are supporting inside the graph is usually about a version, maybe 2 behind. Right? That usually means you have to, with your application, usually support a fair number of the versions out there. Most people today that are building applications are suggesting you at least support anything 2.0 or better, and really 2.1, because really 2.0 was more or less an oops, they had to come out with a 2.01 right away to fix some things there. So most people are either doing a 2.01 or better out there. Questions so far? Yes, sir. Are the versions really backward compatible? I'm going to have to say I don't know thoroughly yet, sir. And that I haven't had enough of an opportunity to work, especially the 1 dots, to know. In the 2 dots, it seems like they're pretty backward compatible. At least I haven't encountered anything yet that wasn't. But what I will tell you is that there are some significant changes in those dot releases. And while they keep things backward compatible, boy, there's some stuff there I'd really like to be able to leverage that you can't without moving up to the latest and greatest. And that's a little bit disheartening. In other words, dot releases to Android don't seem to mean that much. Look at that in some cases as a big, huge full release. So sorry I can't answer that more full. Other questions? Okay. Let's talk a little bit about the Android project. In particular, we'll take Hello to Android so you can get a little bit of it here. As I mentioned, to develop Hello World in Android, 0 lines of code. In fact, 0 anything. If you've got Eclipse, the new Android project, you've got Hello World running. If you don't believe me, you'll get a chance to see it here in just a few seconds. I hate coding, so it'll be pretty obvious that it's in that way. So every new Android project, at least when you talk about using Eclipse. Now, if you're using Eclipse, if you're just using those raw tools that I mentioned earlier, sorry, none for you. You're going to have to build things there from scratch. But if you're building through Eclipse, that's available to you. Take a look at Hello World. What we can also examine here is the Android project structure. We'll get a little bit more into detail on that after we come back out of the demo. We'll see how you can run a project on the actual emulator. We'll also look at debugging. You can do what I call normal Java debugging. Yep, you can put a breakpoint in your code and see how it runs through the editor. But also built into the SDK and built now also obviously into the Eclipse plugin is sophisticated debugging capability based on the fact you're actually going to be running on this device and you want to measure things like an error during the panel. Somebody asked about things like profiling into the application, things of that nature. That's more or less that debug monitor service that's built into the Eclipse plugin. It's a perspective, if you're familiar with Eclipse and different views and perspectives, it's perspective built into Eclipse, and we'll take a look at that in that offer. In fact, it's that latter debugging capability there, the Valve Debug Monitor service that offers us the capability to simulate a call coming in and dealing with those kinds of circumstances. Okay. So with that in mind, let's see if we can go ahead and take a look at Android development real quickly here. Get that all the way. How's that show up? Is it showing up on screen okay for our online viewers? Okay. So I've got a couple of projects already up there. Those are first, and stuff we'll look at later. Let's create a new operating without a mouse, so that's not always a great environment, but let's see if we can do this. Okay, new Android project. So I have the Eclipse plugin built on system in here. At the 3 tutorial level, by the way. There are some great new features coming out for you. I just haven't had a chance to download that. So, hello. Mobile Dev Con will be our project name. You'll notice as I build my project, I have to specify what version of Android I want to use, and including if I want all the extra Google stuff in there. I'm just going to go ahead and pick Android 2.2 application, simple Android 2.2 application. Give it an application name. Now, you have to provide a package name. We'll talk more about that here in just a second, because when you're creating this project, you, at least the world part built in, you're going to create an activity as well. We'll talk about what an activity is. Put mine in com Intertech activities, and our activity we'll say is hello world as well. You also get to specify what minimum version of the SDK you want to support. We'll talk more about that when we talk about what's called a manifest file associated to a project event. But I'll just leave that blank for now. Nothing more required. I'll say finish on that. Okay, so I've got my MobileCon project. Right, we'll talk about this structure here in a bit. But you can see, as you would expect, a source project. In this case, just one file. The hell is an activity file, or I should say an activity class. We'll talk about what an activity class is here in a bit. You also, when you create a new Android project, lots of what are called resource folder. We'll explain those resource folders and what they're right now. But by default, comes up with a lot of things like icons. I think this is the little Android icon, our project. You're building an application, you probably aren't going to be using a lot of that, so you can tear a lot of that out of there when you actually start to build your application. Something called an Android manifest file, very important file. We'll talk more about what that is here coming up as well. Okay, so we'll talk about the piece of the project here in just a second, but to prove that this does indeed work, I'm hoping by the God of demonstrating in a large audience this will work. Now, I've started off there. Whoops. We'll start it off there. And you'll see it's doing some work in the console, getting things compiled, getting things built, things of that nature. I have already started up the AVD, the emulator. Now, the reason I did that is because when you very first start up your AVD, your emulator, look at that. Wow, it actually worked. You start up the AVD, when you start up the emulator, the very first time it'll take maybe, depending on the speed and size of your system, maybe 5 minutes to come up. I didn't think you wanted to hear, I didn't have any more potato chips and Coke to give you guys, so I didn't probably want to sit here and watch the AVD come up for 5 minutes. Once the AVD is up, getting applications to it, you can see it happens fairly quickly. Don't shut it down. When you're building Android applications, the idea is you bring up your emulator, when you're starting in the morning, you do your coding. As you're making your codes and you start things into the emulator, it knows new application or up the application, keep updating it. And then you have that process again. The very first time it takes, again, about 5 minutes when you start the AVD of the emulator. After that, it's not going to take quite long. It still takes, some amount of time. And that is a bit of a frustration point. A lot of Google Android developers talk about, getting the emulator started up is a little bit painful right now. But there's a lot behind it, as we'll take a look at here in just a bit as well. All right, so wonderful, amazing, hello application. Ooh, how about that? All right, Android. Now, let's take a look behind the scenes here to really show you that this emulator would behave. How many people have an Android device? At least here in Hilton? So a fair number. All right, so you've seen, if you haven't, you get a little view into what life on the Android device will be if you go out and get one. So you've got pretty much your standard device here. I can go home and ask for different applications, go out and get the menu. And I think I've cut off the bottom here, but change the wallpaper, set all the settings. It's got contacts already loaded on there. It's got all the same basic stuff that you would have on your app. Yes, you can actually go download other applications and put them on your emulator if you need to. In fact, that might be handy or useful if you're trying to get some interactions and stuff like that going. And remember, it retains all that information when you're shutting down. Now, one other thing I want to show before we go back to the slide set here. How about debugging, Jim? How does debugging work with regard to Android? It would in Java. So let me bring up that activities file. And not a lot in this activities file, but and we'll talk more about what an activity is, again, some code behind it. Let me just put a breakpoint here, if I can get the cursor right. So for those of you who are not familiar with Eclipse development or Java development, what I've just done is set up a little breakpoint in the middle of that hello world activity, that one little part of our application. And now I can just ask to, instead of run that application, I can ask to debug that application. And as one would expect, hopefully. So my application is getting ready to come up, but we shouldn't see here. Come on, system. There we go. It reached that breakpoint, and now it wants to launch into the normal Java Eclipse debug mode. Right? So debugging applications, just like you would debug a normal application. Having said that, yep, you do get some debug information through the normal debugger, and you get your static trace and all that kind of stuff like you would expect if you're building a Java application. What you don't get, though, is what's really going on behind the scenes, what's really going on inside that emulator. Your debugging capabilities here are not as rich as one would probably expect or hope. And so what you're also provided, another perspective, another view built into Eclipse. Again, this is that special view, that DDMS view, the Dalvik debugging monitoring system. This is your ability to see a lot more what's going on behind the emulator. In fact, if we go and take a look at the code, there is a log capability. And logging in the emulator, or with the emulator here, is not coming out in your console like you would see in most application development. It's actually coming out in a log that would be internal to the device. So what you need is this capability to actually go take a look at that log file associated now with the device. And you get a lot more information about what's going on behind the scenes with that, the log information there. You not only get your logs stated out there, but you're also getting logs happening. This is Linux at its core, and so a lot of things are happening in the Linux core, what's happening, get startups, you get things like threads sending off messages about what they're doing and how they're operating, things of that nature. So a lot more information out there in this capability, in this DDMS perspective. You also have the ability to look at things like threads and heap, things of that nature, as I mentioned, even some emulation control, such as the ability to simulate you got some sort of call coming in, or you need to react to that call. How does the application deal with the fact that somebody's receiving a call, and has to essentially abandon the screen for a while that person takes the call. So a couple different debugging capabilities in there. One you're probably very, very used to if you're a Java developer. One that's a little bit new to you. Takes a little bit of getting used to, but pretty convenient to use inside of our Eclipse environment. Okay, go back. So that is Hello World. Nothing too exciting yet. We'll take a look at some other application code here in just a bit. So no hands required to build Hello World. Inside of that project file, let me highlight again some of the pieces of an Android project. Again, you have a source code folder where your application code is going to go. You also have something called a gen file. This is the generated Java files that the environment, the Android SDK, is actually creating for you. In particular, in there, one called the r.java file, your restart file. This is essentially nothing more than a file. If you actually open it up and look at it, and you can, it's just Java code. It's nothing more than a file full of Java static files for those of you who are Java developers. Nothing more than a series of constants. And what those constants point to are a series of resources you have built into your applications. If you need an icon, if you need even a string, you point this file points off to one of those constants. We'll see where those are stored in your application. The reason for this is the particular resources that might actually be bundled up and put on your application, again, might be different depending on which device you're going to support. On a tablet, much more space. I guess I can't draw it in the air that big, but draw a little bit smaller than that. It's going to be bigger than what you got on an handheld smartphone. So the application environment, your project environment, is set up such that each of those resources can be sized appropriately. Right? We'll talk more about that in a second as I go down the stack here of what's in that project. That is generated code, by the way. You don't touch that. In fact, if you do touch that, bad things start to happen. You just don't want to touch it. Leave alone. I have actually started to by accident make changes in that, and really you have to almost start to unwind the application and do some nasty things to get you back on track. So leave that code alone. There have been people suggested, is there a way maybe for us in Eclipse to start to hide some of that and kind of get it out of the way? Yeah, it's there, so if you have to look at it, you can go find it. But the way it's just portrayed right now on your application is you can see it's easily available to you. What else is out there in your project? The Android project can be set up with all sorts of resources. I'll tell you some folders, really. And if you take a look on there, you'll see that in particular, Android by default sets up all of these drawable projects with drawable HDPI, I should say folders, HDPI, drawable LDPI, high, medium, and low density, DPI for the dots per inch. What they're doing there is providing for the capability your application will run on, again, multiple different sizes and shapes platforms. Or you may need those particular images, in this case maybe the PNG file, to be a different size as you rotate the device. So you may want a particular image to be bigger when somebody's using it horizontally versus vertically. Android knows how to deal with that under certain circumstances, and this structure allows for that capability, that flexibility, if you will, for offering the device code essentially be the same, but what gets represented on the screen might be different based on your particular environment or the environment that the application encounters. That even goes down to strings. They even have in the file, you'll see the strings XML. Everything that could possibly be represented and or displayed, they want in a resource file. It's funny, you might think, well, geez, why in the world not a string? I was building little sample apps for this demonstration and this talk, and you don't even think about it, but things like title bar, it's only so wide when it's vertical, and then you rotate it, and it's like, oh, now we got more room. You put it on a tablet. Oh, now you got lots more room, right? So those little things you have to think about when you're building applications in these device platforms, and that's how Android provides that capability. Beyond that, not much really left to talk about other than the manifest file. The manifest file is where we describe all the components of our application, and also where you specify things like the version support and more. We'll talk more about that very important file in an Android project. The rest of your stuff. And I've had questions from people before saying, well, now what if I have, for example, a library, Jim, a jar, that is code that I've used in maybe my enterprise application. Can I put that in there? Sure. Yep. Put your jar files in there. Now you have to be careful. Remember, this is a Java environment, so it is Java code that you can put in from any jar file, but it is not your Java SE environment that you get from Sun, nor is it your Java enterprise environment. So there are pieces and parts of that thing that aren't going to work in the data virtual machine. You put something in there that uses Java NIO. For those who do Java work, the Java native I/O capability. For those who don't do Java capability, it's essentially to go down to raw hardware and figure out how to deal with what output. Yeah, that's not going to work so well here. Right? So you have to be very careful about what you put into that environment. Okay, questions? Yeah. Oh, yes, sir. We have plugins for protecting any memory leak. It is Java, and so there is garbage collection and things of that nature already out there. There are tools to help you find, we don't like to call them memory leaks in Java. We like to say, resources we haven't cleaned up around. Things like collections and stuff where we didn't release memory. It's not like a malloc situation, which Jason will come up here and tell you all about with regard to iOS, although even he says there's lots of help there. We don't have those kinds of memory leaks, but you still have those capabilities where you could create an application that's hanging on to something too long by just poor coding. There are some capabilities that again, the debugging capability I showed you gives you, or can give you, some indication of how much memory you're using, and you start to see whether or not that's growing or shrinking. There are also third-party tools out there that can help you. Oh, by the way, it is Java still, and so there are some capabilities to attach normal Java profiling type tools to this environment. You got to remember, this is the Davic virtual machine, not the JVM that's offered by Sun. So if the profiling tool you use is into the JVM, probably not going to work in this environment because it's different, JVM underneath the covers, or I should say, can't say that Oracle would get really plural now. VK underneath the covers. Okay, good question. Others? Okay, how about let's look at something a little bit more industrial strength, Jim. What about some real-world applications? What are the building blocks? What does some of the code look like for something beyond Hello World? Well, Android applications are really a affiliation components. Android likes to talk about really you're not building an application. You do, obviously, but you really want to build or think about building a series of components that work together. Some of those components are UI. Some of those components are services, or messages, literally processes that run in the background and don't even have UI to be heads. Some of them are communication mechanisms that go back and forth. Some of them are things like content items, which provide the data to our applications, and data store through. Right? So there are all these different pieces, activities, intent, services, content providers, and others we'll talk about that help to build quote-unquote your application. But they each can be used individually. And they each can be used, if you so desire, and you set them up this way, by other applications in that environment. Unlike some of the other platforms you'll find out there, Android is, or at least tries to be, very open and saying, we'd like to build an environment on which, as you build pieces, other pieces can be built on top. And you should be able to take advantage of other things in the environment and not have to know all the details about that. So it's kind of that open airness that is fostering a lot of security so that you don't have to build every single piece of this application. We'll talk about each of those. All these components are specified again in the Android manifest file. If you're getting a sense that that manifest file is an important and critical part of the Android application, you would be absolutely correct. Now I'm going to show you a couple of applications here, demo applications. They aren't toys. They are something that's not really, really fancy. Good news is you actually get to see them on the device. Jim's not lying. They actually run. They're running on a Thunderbolt, something I got just a couple weeks ago. A chance to play with my new. And you'll see, while not exciting, not particularly business oriented, what they will do is show you each of the components that I'm talking about, at least the major components that most applications are consistent of. Activities, things like, again, like content providers. So you get a picture of how these all kind of work together to put an application to work, but not obviously in a real business sense. And by the way, not all the best practices that Android and the Android community would suggest built into these applications. They're there simply to show you the technology. I'll leave some of the more details for later. One application I'm going to show you, I think I call the reverse application. Really tough app here. I'm going to give you a string or give the application a string through a user interface, and then the Android app will reverse that string. So I'm sure that's a business component you need all over the place, right? So if I give it my name, it'll put it up backwards, right? And what does this demonstrate? It's going to show us the windowing capability, UI, intents, which is the masking capability, show us back-end processing, as well as notifications and some of the other capabilities out there. So again, we'll put it in a frame. We'll hit the button, and through something called a notification in Android, for those of you Android device familiar with notifications, they're going off all the time when phone calls come in or emails come in. You can see a notification that will actually show you what the reverse string is. Okay. So let me show you reversey working, and then we're going to take a look at some of the code behind it. All right, let's see if this will work here. Gods of demo are with me. Is that coming through there pretty well? Everybody see that, or we need to brighten it up just a little bit? I'll see if I can brighten it up just a bit without wiping things out. Okay, so live device. Let me go out, start up reversey. So I put a string in there. E, B, C, D, E, F. Okay. So I didn't type. You can see my fingers don't always hit these just right either yet. So I've got a string in there. I'll ask to reverse this string. And I don't know if you saw the little notification come up at the top. It was that quick, and obviously reverse the string. How do I get to see that reversal? Go back down through my notifications, and there it is. That whatever the string I entered in there, what was it? A, B, C, D, R, F got reversed. Okay. And actually, if I actually punch on that notification, it takes me right back to the application too. Again, nothing fancy, but it helps us see the different pieces out there. I'll show you another application here a little bit later on, if time permits. I don't know if time will permit. If time permits, I have another application out there, a little bit more business-like, although again, still a toy. An application that allows attendees to something like this to introduce themselves to each other. You provide some personal information into a UI. That gets sent to a server back end. In fact, it's actually a server piece that I've put in Google App Engine. If you're going Google, go Google all the way, right? So an application piece running in Google, and then that information is then displayed on the device through WebKit. That shows you all the attendees and where they put in as their zip codes on a map. Okay? This demonstrates a lot of the same capabilities, things like activities, services, but it also demonstrates a few other things. The WebKit. So how you actually, somebody was asking about hybrid applications, and can you build things that run kind of in half on the app and half through the browser? The WebKit is Google's way of offering that directly through your applications. Android preferences. Android has a built-in capability for, if you want to think about it, a fancy INI properties file type of capability, but built right into the application that your application can take advantage of. It's built into the system. But you can specify, I want to have these preferences and have you be able to set these preferences and then use those preferences in your app. The nice thing about that, you don't have to build the UI, you don't have to use the main, you don't have to do anything. You just essentially say, I want it, and there it is. And even allows us to look at the camera API. So you can take a picture of yourself and include that in the information that you would potentially send to the server. Although Google App Engine doesn't allow for you to actually download or file your system, so that part of the system would have to be hooked up by you. And also HTTP client, so you can actually integrate to that server and see how an Android application can communicate with the server. So that application is out there. Again, we may not be able to cover that today, but all the code, and I'll give you the link at the end of our talk, is available for all these applications and demos that I've shown you out there today, including this one, and even including the server-side stuff. So if you want to get it all up and running yourself, it's pretty easy to do. So that's what introductions look like. You put in personal information, hit the send data button, and what you get back is the ability to see you through a map. Okay, let's take a look at an Android application and talk more specifically about some of those pieces out there. The Android manifest, again, is the key ingredient to the Android app. All applications must have the Android manifest.xml file. Usually this is where I get screaming and gnashing of teeth. People are like, you're kidding me, really? We've got to do XML to put together applications? Yeah, there are parts of the Android application which are XML-based. Yep, that's probably different than a lot of the other device manufacturing that's going on out there. I should say application for devices out there. It has to be in the root of your project folder. And the nice thing about the XML, if you're doing it again through Eclipse, there is an editor out there. So you don't necessarily have to do anything by raw XML. They do provide a UI to allow you to enter that information in. Once you get used to it, most people find it's just as easy to do the raw XML. But if you're a hater of XML, sorry, you got to have this file out there, and everything in your application has to be registered through the particular XML. So your user interfaces, essentially, what we'll call activities, your services, how you communicate, everything is in that XML file. That manifest file also contains, in addition to that, things like your user permissions and your application permissions. What do you need? Maybe you want to use the camera. Maybe you want to use that contact database that's on that person's device. That's fine. You can ask for that, but all you can do is ask for it. When the application gets installed on your device, no matter how you get that application, whether it's the Android market or try and go through USB, that application, when it tries to get installed on that device, is going to come back and ask the user, here's the things this app wants. Is it okay if I proceed? Obviously, if they say no, none for you. It has to be an acknowledgement on the part of the user that, yep, I'm okay with this application using this part of my system. To include, even, you can go access the telephone. You can make a call, get a call, but you have to have the user's permission to be able to do that kind of thing. Conversely, you have the ability to set up permissions for your application components. Let's say you've built the world's best little database, and it's available out there on the device. You could make that available, that database, available for other apps to use, not just yours. If you want to give others permission to that information, you have to provide that to the Android manifest file. You have to provide that signal out to the Android environment that says, hey, here I am. I'm available for use. So this is our way, essentially, of communicating to that environment what we need and what we're providing at the same time. There's the Android manifest file in all its ugliness. I don't expect you to look and know all the pieces, but as I mentioned, you can edit that in strict XML, but there's also the manifest editor. As we go through the demonstration, some of the components that are in this little application, we'll come back to that NFS file and see how you register pieces into that file. So your choice, whichever one you want to use to provide that information, but you do have to provide it. Importantly, you will notice that you have to provide things like the version of the SDK that you support, minimum and maximum. You don't have to say what those are by default. You're going to say essentially I support all. You probably want to tailor that down to a subset. You also have to importantly provide a version number and a name for your application. And that's how the environment, the Android environment, knows when an update is coming in. You've got to remember these are applications that are living out there on a device, and maybe the user chooses not to get an update of your application in some time. How does the device know that? When does it know to upgrade versus install? You have to actually, as part of the deployment process, give it an actual version number. Okay, let's talk about the major components, and in particular start with where everybody likes to start, UI. What is the UI mechanism in Android? It's called Activities. This is your user interface, your visual user interface, the screen. When you hear the word activity. Only one is visible and active at any one time. That's across all apps. It's one of those cases where it's all or nothing. There's no split screens, no scroll bar to down to the other screen. It's one activity at a time is displayed to the user. There are other things that might look like they are activities or user interface parts, but really it's just one activity at a time. Most applications obviously are going to have at least one activity, might have many more. The first activity typically gets open when the application launches, but it doesn't have to. In fact, you can have headless apps in Android. You can have nothing but a service and data being allowed out there. Right? The interesting thing with Android is these activities are as live only as long as Android sees fit to allow it to live. Now, on what criteria does it base things? Well, no, it's not just because it thinks your UI is ugly and doesn't like the color purple. Right? There's other criteria there. In particular, what else is going on? Is too much memory being used at any one time? It has to start to kill off activities. Is the phone all of a sudden, and now the user wants to switch over to that phone? That's what dictates whether or not that activity stays up. But importantly, you as a developer have to build into your activity and code that activity may be taken away, may be paused, stopped at any time. Right? An interesting concept to get used to. We're used to applications kind of being in charge. You're not in charge of Android. Android is in charge of what's on Android. With regard to activities, what's being displayed, you can only hope that what's up there is going to be up there for some time, but you have to anticipate it might be taken away from you at any moment. Inside of an activity are things called views and view groups. Think widgets. Think view groups as being layouts or collectors of those views widgets. We'll take a look at the popular widgets that are available out there. You can specify these in Java code. I find XML is actually not too bad. See here you can write programmatically your user interface or declaratively. And we'll take a look at both here. And while I'm not a fan of XML, I can see certainly some people are a little bit disgruntled with that. Yet you can do everything in strict programmatic fashion if you so desire. So how do you create an activity? Again, for those who are not Java developers, I apologize, don't want to give you too much Java code to be oohed and awed by. What I'm just trying to do is essentially give you the highlights about what the complexity is here. And when you think about building an activity, it's not that bad. You take the activity class that Android provides and you extend it. And that means in extending it, you also have to override two methods. The onCreate. OnCreate is one would probably expect. That's where any kind of initialization gets done. And on the set content view, this is where you determine what's going to actually be seen. Again, you can do that from a declarative perspective or from a Java code perspective. So it's in that set content view. You might have some Java code to say, show these widgets and these buttons. Or it might be, this is the XML I want you to go see and build my UI for me based on that XML. We'll take a look at both of those. Now, when we talk about widgets, the views, what do you have available to you? All the standard stuff. Nothing real exciting here in terms of what you probably wouldn't expect to see in any platform. Yep, Android, like a lot of the device platforms, has tried to offer some sophistication in some areas, for fancy selection mechanisms and things of that nature. But essentially, it all boils down to, at its base or its root, these kinds of widgets that you'd see on any platform. Here's how you then register that activity in your manifest. Excellent. And remember, you have to have that XML. Yep, you can go back UI to essentially build this XML, but you have to specify your activity. Now, even though some of you may either not read XML or don't want to read XML, and even though I don't anticipate you to be an Android expert, you could probably tell, though, in the middle there of the red, where we've listed the activity and its name and its label, you notice that there's that area called intent filter. We'll talk about intent filter here in just a bit. But notice inside of that something called action in main category launcher. Okay, no rocket science necessary here. What do you think that probably does? It's telling Android, when I come up, this is the main window, right? This is the main activity to launch when the application starts up. Right? So you can specify a particular activity like that. Say, this is the main guy. This is the one that will kick off when my application kicks off. We'll talk about what intent filter is all about and why that's there in a bit. Now, for those who maybe do some Java work and have dealt with AWT or Swing, here's a loose translation I found on one blog site that I thought was a great way for those who are trying to maybe get their arms a little bit around the UI part of Android. Activity loosely equated, these are not one for one, but loosely equated essentially is your JFrame or your frame in Swing. And then you can see the other view components and how they equate essentially to your Java world. Again, view being kind of any loose widget, but then there are specific types based on what type of entry you're trying to fill out. And the view group essentially serves as your layout manager. That is one thing that a lot of people just do play about. There are dozens and dozens of very complex, what we find to be complex kinds of layout mechanisms to end have. That's the unfair part. I'm trying to figure out exactly how them work and things up. It seems to me a bit random on occasion, but that may be just because I'm not very good at it yet. My UIs are usually pretty ugly. But that is one of the complexities, is trying to figure out those layout managers and how to get all the widgets aligned just like you'd like. Now, as I mentioned, when you build UI through the activity, you can do that setting the content through Java code, as you see there on the left, or XML. Right? Now, I don't expect anybody to be able to take a lot out of that in terms of I'm not expecting you to go, oh, yeah, now I see exactly how to build an application with Android. No, but it's to give you the idea that, you know, when you're talking about a UI, those two sides of the screen there produce the same output. Right? So when you're talking about lines of code, usually not that much difference, at least at the higher level of things. You start getting a lot of specific attributes on widgets and things can get a little bit more tricky. But it's usually about the same. It really is. If you're doing it in XML, however, and you're doing it through Eclipse, Eclipse does provide a crude kind of drag and drop visual editor as you're building the XML. It will actually help put together what it sees or simulates as a view. It is very raw. This is going to come up and show you iOS and development and Xcode a little bit later on. Oh, what I wouldn't do for a UI editor like that in Android. Right? It's just not there yet. It's crude. It's ugly. It does a little bit of a job helping you kind of assemble the UI by thinking in terms of the visual versus having to write code. But you have to kind of do that in that form of XML. Of course, you can start with the Java code. It's going to be generating the XML code anyways, and then you can, or I should say, you can generate the XML code anyways, and then go back and do that. But the XML code is what's really used by that user interface mechanism. That's where a lot of improvements I'm hoping come about on the Android platform, is through some of the tools and making this a little bit more of a visual environment, which it isn't today. Again, output is the same. Again, we tie that output into that set content view. So you can either put the Java code into that onCreate method or the method to set the content, or you can put it in the onCreate method by calling. Remember that r.java file? As I said, was just a constants file. That r.java file, you can specify in there a constant which says go read, in this case, the main XML, r.layout.main. Go read the main XML. That'll tell you exactly what I want in this UI and set my content that way. So either way works. Either way is just as effective. It's up to you as to which you prefer. Both are going to come out with the same UI. Questions there? Okay. How do we get to interact then with that UI? Well, there is a simple approach. As you're building your application, again, either through Java or in this case I've shown it in XML. When you define, for example, a button, as I've done here on the left side of the screen, you can add an on-click method indicator. And then in your activity, have that method. Obviously, when that button gets clicked, that method gets called. Whatever code you have behind there now gets executed. Right? That's the down and dirty, simple approach. Probably not the recommended approach, by the way, because your UI you might want to have a little bit more loosely coupled to other things in your environment. We'll talk about that and a better approach typically for doing that. But essentially now your method is a listener, for that event, that on-click event, and now it's ready to receive and do work based on the pushing of that button. Let's talk about deeper. Once we've gone past the UI, services are typically running in most Android applications. What are services? Background processes. A cron job, things scheduled task. No interfaces on these. No UI, or at least no direct UI. They can communicate back out to UI, but these are strictly processes. You want to play music. You want to update something based on a feed. You usually do that through a service. These are alive as long as they have to be. They're long living. Remember the activity? And it can say, you, out of the pool. None for you right now. Right? Services, Android's not going to do that as much because these are going to be running at a higher priority. If it absolutely must kill a service, you're out of memory, something's going wrong, that service can't survive anymore, then Android has responsibility to remember that and restart that service for you. You can't configure it to say, well, I don't want that to happen, but services, therefore, are meant to be out there and running for as long as you need them, and Android will help maintain that. Activities, not so much. You have to manage that. When Android shoots one out of the water and says, you, away from here, you have to figure out what happens when that UI needs to come back. All right? Now, Android, with the services here, again, provides them a higher priority than the activities, in particular the inactive activities. Obviously, if it's an activity, a screen you have up and you're viewing something in, that has a pretty high priority. But if it's just sitting out there not being used, it has a pretty low priority. So Android's way of dealing with that is giving the services higher priorities, and they're kind of what's in control of the applications. Services are really considered the strength of Android, because essentially, as you might expect, with the Linux kernel at its core, right, we're really talking about a mechanism out there for where Linux processes running around and being able to do work at your disposal. And that can be very difficult to do in other platforms. In particular, do it in a way that's completely headless. In other words, where you don't need to build anything else to build a service and put it out there in Android. You can build applications that just run as services and have no head on them. That's pretty convenient and not always available on other platforms. So this is considered one of the strengths of the Android platform. You can also expose those services to other applications. Essentially, creating your own little mini web service. No, I know it may not have all the XML and SOAP stuff associated to it directly until you build that in, but essentially it's its own little web service out there running in Android if you so choose. How do you create a service? You extend the service class that Android provides, and you minimally override the onCreate, or again, initialization is there, and the onBind method. The onBind method is a method that allows for more direct communication between, say, an activity, a UI, and a service. So if your UI needs to talk to the service, communicate back and forth a lot, you can do that through essentially the onBind method. In most cases, you're also going to want to implement what's called the onStart command. This is where you usually put your code that as the service comes up and is going to continually execute, this is where you put that kind of code in there. In fact, for the reverse C mechanism, I built the reverse string operation, as you can see there, for those who read Java code in that onStart command. Questions so far? Okay. Again, everything has to be registered back in the manifest. So here's how you register the service in the manifest file. Usually it doesn't take much to register a service because it doesn't have any UI. You know, it's triggered by other things out there. So usually it's just a matter of dropping out a single line of XML and say, yep, here I am, I'm ready to run. Now you can trigger that service from an activity. Simply call start service. It also requires an intent. We'll talk about what an intent is here in a bit. So essentially, in this case, for my reverse C app, when I push that button that says reverse it, that's actually triggering that service to go out and reverse the string and then send out a notification when it's done. When we talk about that code that actually does that, for those, again, who are Java aware, here you can see the 2 lines of code essentially in the activity to kick off the service. You have to create an intent. Again, we'll talk about what an intent is, but for all purposes right now, think about an intent as simply a message. Once you've got that intent out there, you say start that service by essentially passing in that intent that says start that service by this intent. Now, what exactly are intents? These are our system messages, event carriers, announcements. Use whatever analogy works best for you. This is the main means of communication in and around Android applications. And they can communicate in-app or outside of app. Again, the term app kind of starts to lose some meaning in Android depending on how you think about applications. This is a way for us to have an activity call another activity, an activity call service, have a service call back to an activity. Any kind of communication amongst your components in Android is typically done through intents. Android controls delivery. So you don't have to do anything essentially other than say, here's an intent, create an intent, a message, set it out there, just like we saw with regard to start service, and Android takes it from there, gets the right component that it's destined for, gets that intent to that component, and allows it to take whatever action is necessary. So if you really can think about Android essentially as having its own message framework underneath the covers, and intents are just the way to communicate with that messaging framework. You can think of intents as action plus context or data. In the example I showed before, it was really more just a message that included an action. It didn't really have any data, but it can include both. In fact, it's not unlike how REST works. With REST, if you're familiar with RESTful services, you send some sort of URL out there that says, get me the customer record 123 in URL format. That's very similar to the way that the intents work. For example, an intent action might be something like view or edit. And then the context or the data is something like the URI of one of your contacts in your contact database on your Android device. So essentially, edit contact 123. Android will go around, run around, find the contact application, bring it up, and allow you to edit that contact 123. Now, there are different types of intents. There are what we call explicit intents. That's really what I showed you in that example, where you say to a service, start yourself. Here's a case where we create an intent that the intent action is reverse service class, go start up. That's explicit. That's a raw message from one to another. You can also do something like have a call for an activity to start up based on that same mechanism from either a service or another activity. Give an idea how that works. Create an intent. I want to start some activity. Go start that activity based on this intent. Right? So that's explicit. Go do this type of instruction. But intents can also be set up to say, hey, I need some action done, and here's some data. Anybody help me with this? So essentially a message out to the Android world that says, I'd like to do X with Y. Can anybody help? And the Android environment will actually help you there. It'll go find out others in that device, other systems, other components that will do that and help get whatever job you've asked done. So here's the implicit intent example for my reverse service. Rather than creating an intent and then saying go loft the request service, I create an intent. And I say my intent is just going to be called the request reverse. It's kind of a loose name. You set up your own contact there, or your own constant there. And then I pass it in some data, in particular the string that I want reversed. And just say this is plain old text data there, Android. Right? And then I send that message off into the world. Here, Android, start this service. I have no idea what service is. It may not even be in my application. All I've said is, go find something that will do this, and here's the data I want reversed. Right? Now, obviously, in my application, I built the service to react to that message. But there could be a case where something else out there knows how to deal with request reverse, and it deals with string data. The idea here is there's now a loose affiliation, a loose coupling between your UI and your backend, or other UI components. Loose coupling not only within your apps, but a loose coupling to other apps. In the manifest file, we see those intent filters out there. That's designed so that as you build any component in your system, you're also registering who you listen for, what types of those intents you listen for, and what data you expect. So it's our way to say, hey, I'm this kind of service, and I'm going to be listening for this kind of intent, this kind of message, and I'm expecting this kind of data associated with that intent. And if I hear it, I'll deal with it wherever it comes from. I'll take action. Right? So a way for us to build some very loosely coupled apps out there. In a service to get things going, I just replaced now for my reversing service, the way to deal with that, the way to get the data out, you just simply ask the intent, hey, give me that data. In this case, it was a string, so just give me that data string. So getting information out via message is actually pretty straightforward. Android has a lot of built-in intents, built-in messages, if you will. The action to dial, somebody's to dial a phone. Actions such as editor view, as I've shown earlier, for dealing with things like contact information and your other databases that might be out there. The battery is low. Android sends off a message saying, hey, we got a low battery issue here. Anybody need to deal with that? Your application, if it wants to know, oh my gosh, we're about to run out of power and may need to do some things critically before it all goes to heck in a handbasket, can take advantage of that now. Right? And then there are simple data URIs that are already available and known to the Android system. For example, that's how you represent a telephone number and broadcast that out as part of an intent. Telephone or TEL and then the digits behind it. there's a contact URI. If you want to talk about the people in your contact databases, they're all referenced by a particular ID. And even URLs, again, if you need to pass around a URL, as one would expect, that can be sent as data. So Android already knows how to deal with some of these, and your application can take advantage of that. Lastly here, before we take a quick break, I want to talk about the content providers. What are content providers? Content providers are your data store, or a fake data store in Android. An abstraction, as you'll see. And no, it's not the SQL relational database, right? It's simply a mechanism for us to store data, just about any type of data we like, but store data in our system. And it's also a way for us to share data amongst applications outside even of your own application. All data in this data store is identified or addressed by URI, just like the contacts are in your contact databases. So Android ships with a number of those content providers. For example, your audio, your video files, your camera pictures, things like that are all in a content provider. Even your call log is in a content provider, and you have access to that from your applications. But you could also define your own, as you would probably assume. The way that the content provider works is your application deals with what's known as a content resolver, and then that content resolver is really negotiating with the actual data underneath the covers. What you're dealing with is queries, not totally unlike SQL, although they're in more URL format, and a cursor to get back answers. So yep, you can do things like insert, delete, updates through that resolver to the provider, and get back what is a poor man's cursor to get through that data in case you queried it. Here's a little piece of example of content resolver code to get access to, in this case, the contact database. In fact, I can actually push a button on my little screen out there, and it goes and loops through all the contacts and just shows you them on the screen. But essentially, go through the contacts provided in my content provider store, long sentence, and just show them up in the log. Okay, that's probably a good place for us to take a quick break here this afternoon. Questions, comments, concerns? Yes, sir. Yeah, great question. Great question. Yeah, if there are multiple, Android detects multiple event receivers, it will come back saying, I got these guys that could react to that. Which one do you want me to give it to? So yeah, if you're competing then with an application for that intent, right, and maybe directly so or indirectly so, the user is the one who ultimately gets to choose that. And of course, you can limit your intents just to your application too. Yes, sir. There are at the end of the class here. Oh, I'm sorry. Yeah, are there sites out there for sample projects and sample code, things of that nature? There are. At the conclusion of this talk today, I have a list of resources out there to point you to. Okay, folks, let's go ahead and take a quick 5-minute break. So I've got 2:20. Come back to 2:25, and we'll wrap up our Android discussion.
Launch an activity.
Yes.
Basically, like your reversing service can launch an activity which could play a different page.
Yep, it could. Yes, sir. Yep. Is that me or you?
You're still not there.
Yeah.